Good afternoon. Nagdev ma'am, you can start.
Sure, ma'am.
Yeah, thank you.
A very warm good afternoon to one and all gathered here. I'm very happy to welcome the speaker for Dr. S. Kalyani ma'am, Head of the Department Electrical and Electronics Engineering of Commerce College of Engineering and Technology. She has completed her UG degree in stream of Electrical and Electronics Engineering in College of Engineering and Technology, Karaikudi in the year 2000. She received a master's in Power System Engineering at Tyagaraja College of Engineering in Madurai at 2002. She got a PhD degree from IIT Madras during July 2000 for the thesis work titled A Unified Approach to Power System Security Using Pattern Classifiers. She has about 17 years of teaching experience. She is currently Dean Examinations and Professor in the Department of EEE, awarded with Outstanding Faculty in Engineering by Venus International Foundation during July 2017. Published about 24 papers in international journals and 4 in national journals, out of which 14 SCI journals. To name a few, IEEE Transactions in SMC, Part C Application and Review, International Journal of Electric Power and Energy Systems, Applied Soft Computing, Expert Systems with Applications, Atomica, Soft Computing, Pattern Analysis, and Application. She has presented 32 papers in international conferences and 25 national conferences, out of which one in Singapore. She has got a funded project from TNSC-ST during July 2014. She has received a grant from AICTE under ModRods and an FDP and grant for organizing conference during 2019. She is reviewer of many reputed journals in Elsevier. Her areas of interest include power system dynamics, stability, machine learning techniques, pattern recognition, artificial intelligence. She is a life member of ISTE, IE India, and also a member of IEEE. We kindly invite you to share your expertise, ma'am, please.
Thank you very much, ma'am, for the introduction. So once again, a warm good afternoon to all the participants of this STTP program. So you are now in the 5th day of the STTP program. Very happy to see your active participation. Let me share my presentation. Please give me 1 minute. Is my presentation visible? Is my presentation
Yes, ma'am.
visible? Yeah, okay. Thank you, ma'am.
Yes,
Thank you,
ma'am.
ma'am. Okay. So the topic which I have been assigned to talk about is machine learning techniques in electric vehicle applications. So before I start off with the topic, I would like to thank the coordinator, Dr. D. Prince Winston sir, for having given me an opportunity to get connected with the participants of this STTP program, who are the teachers, eminent teachers who have from various engineering colleges from various states of the country. So before I go on to the topic, I want the sessions to be more interactive, and so that it will not be a monopoly. I want all of them to be equally participating in this. See, although I have been assigned the topic machine learning techniques in electric vehicle applications, I have extensively worked on the various machine learning algorithms. My PhD topic itself was using machine learning only. I have done for power system security assessment using the various machine learning algorithms. So I am proficient enough to talk about machine learning. But coming to the electric vehicle applications, I have not yet started the applications, but I've just had some overview of that. So the major part of the presentation will cover about the various algorithms and how to go about in applying machine learning for any particular real-time problem. And at the end of the presentation, I will just touch upon the electric vehicle applications. Hope this will be convincing for the participants. So before I start off with the presentation, can anyone unmute and tell what you have heard about machine learning, or in your context, what you think machine learning is? Any one of the participant, you can unmute and tell whatever comes to your mind. what do you think of machine learning? Hello. Whatever you comes to your mind, you can tell. Any one or two can unmute and speak. Hello. Hello, please respond. Otherwise, I'm just sitting in front of a computer and talking. So it's really very difficult to cope up with this online classes where we are not able to see the people face to face. Yes, please. Just tell me one or two words which you have heard of when you think of the word machine learning. Or else at least put it in the chat box. If you feel difficult to unmute and speak, please put it in the chat box. However, I will not be able to view the chat box. If anything is put in the chat box, Nagdev ma'am, you can just tell me.
Sure, ma'am.
So I want the session to be more interactive. Otherwise, there is no point.
Ma'am, one of the professors answered AI techniques, ma'am.
Very good. Thank you, sir. Thank you very much. You have given the right keyword which is associated with machine learning. Thank you very much for your response. Going ahead with the presentation. So this picture, most of the resource persons have shown you over the past 5 days. You have undergone a lot of sessions by eminent resource persons from various reputed institutes and industries. So I'm not going to talk anything about the electrical aspects, what will be used in the electric vehicle. I'm just going to talk only the machine learning algorithm. But here, if you see, in an electric vehicle system design, you are having the battery backup. Yes. What machine learning is, what role machine learning has to play in this design of electric vehicle? Is there a role for machine learning to play? Yes, there is a role. Where there is a role. See, whenever you think of EV, the main thing is first is, as morning Shankar Narayan sir told, that simple block diagram he told: charging, battery, and then power controller, and then motor, and then wheels. Okay, so when you want to work on the battery management system, which is a very important aspect in EV design for its betterment and for its better efficiency, definitely machine learning will play a vital role in this BMS system. Okay, so there is a battery management system. So you can analyze the state of charge analysis, what will be the charging capacity of the battery. You can predict, you can work on different types of batteries, and you can see which battery will be more suitable or which motor will be more suitable for such type of things. Predictions, you can use machine learning very well, right? So it will be used for wherever you have a lump sum of data and you want to predict what will happen in the future. Machine learning is definitely helpful in that aspect. So machine learning algorithm has a vital role to play in battery management system, which is a major part in the design of electric vehicles. For that only I have shown this picture to you. Right. Now coming to the second picture, machine learning, right? So the topic EV, first slide I have shown, and then this is machine learning. So this is just an overview of the various types of machine learning algorithms. However, we will be seeing in detail in the forthcoming slides. So when you think of machine learning, basically you can classify machine learning into three types of learning. So first you understand the word machine learning. Okay, learning is there. Learning is nothing but improving through experience. Oh my God. The slides are not visible. I have gone to the third slide.
Yes. It is in the first, ma'am.
Slides are not
It is in the first
visible, madam.
slide.
Just shows the inner only.
Okay. Wait.
Put FI also, ma'am.
Madam, if you don't mind, if you make it into the full screen.
Yeah. Wait. Again, I will share it. Is it visible now?
Ma'am, not in full screen mode, ma'am.
Madam, please put FI.
Yeah, that's what I am putting, sir. I am putting FI. In my host screen, it is coming.
Ma'am, in the screen, you have to give the desktop option, ma'am. First option. While sharing, the first option should be given.
In the screen, Jesslyn ma'am, can you help me? What I have to do?
Ma'am, while sharing, ma'am, give the first option, ma'am. Desktop.
Okay. Right.
Yes.
Thank you, Jesslyn ma'am, for helping me. Okay. This was the second slide which I had. So this picture, many of the resource persons have already shown you. I was talking about the role of machine learning. So machine learning has a vital role to play in the battery management system in the design of EVs. Okay. Now, talking about the machine learning algorithms, you can classify machine learning into three types: supervised learning algorithm, unsupervised learning, and reinforcement learning. So anyway, we will see in detail in the forthcoming slides about this, but understand the meaning. See, whenever we name anything, everything has a meaning. See, everybody has given you a name. Your parents have kept a name for every people who is born in this world. So there is a meaning behind your name. When a country is named, when a place is named, everything has a meaning behind it. Similarly, why the name machine learning is given. Learning, the word learning, why it is given. Learning is improving the performance. Say today you have attended this STTP program for 5 days. Before attending this STTP program, your knowledge on EV will be just the base level. Now you have understood a bit more about EV, and you can even submit some projects based on the EV which you have learned through this STTP. This is what is called the learning, right? So please unmute, participants, unmute your mute your audio. So supervised learning and unsupervised learning, in that we are having in supervised learning classification algorithms and regression. Regression is something like prediction. Okay, see the examples given here. Advertising popularity prediction. Okay, weather forecasting. What will be the weather the next day? Today is 33 degrees Celsius. What will be the weather tomorrow? When the rain will come? Okay, when will be sunny days? All this weather forecasting. Market forecasting. Today the trend is, you know about engineering, right? So today the trend is only for CSC. What will happen after 4 years? What will be the trend? So we need to work on the prior data, and we have to predict the market and estimating the life expectancy. Okay, this also I told that even the battery life you can predict using machine learning algorithm. You can see when the battery will expire, or when how long the battery, the state of health, which morning Shankar Narayan sir was talking. You can work on state of charge and state of health characteristics using machine learning algorithms. Okay, similarly classification is something like dividing into different categories. Suppose if you have in a bucket, you have lot of apples, right? You want to sort which apples belong to category 1. See, in the fruit shop when you go, they will be keeping 3 baskets. In each basket, different category of apples will be there. They'll be telling that this is 28 rupees per apple, or this is 33 rupees. The cost will vary. It all depends upon the different hybrid or whatever varieties they are having, right? How they are doing, for that also we can apply the machine learning algorithm to sort and tell that this belongs to group 1 and this belongs to group 2. So such type of classification we can do. So image classification, customer retention, diagnostics, very well helpful in the medical field, where we can see whether, for our own case, for the present scenario, you know about the COVID situation which is prevailing. Okay, so COVID also we can apply a lot of machine learning. They have already applied a lot of extensive research has been done in IIT using the COVID data, where they are predicting about the death rate and also which age group people are more affected. So which region is more affected, why it is affected based on the weather conditions. All these predictions, they are taking the input attributes and they are classifying it, right? So this is supervised. Now unsupervised learning, you are having clustering. That is one particular aspect of machine learning algorithm. And another thing is dimensionality reduction, where we'll be reducing the number of input attributes for the process of machine learning. Okay, we'll be seeing in detail about all this, don't worry, right? And reinforcement learning is another new type of learning which is introduced and which is mainly used for robot navigation and real-time decision making. It is like an agent-based application. Okay, however, in my research I have not used reinforcement learning. I have used supervised learning and unsupervised learning. So the further slides whichever we are going to talk about will focus only on these two types of learning algorithms. Now, what is machine learning? Let us start with what, why, and how. That is the three words we have to follow whenever we teach any particular topic, right? So what is machine learning? You think of this famous personality, Herbert Alexander Simon. See, nowadays, if you see recently, machine learning is blooming a lot. So people are talking a lot about machine learning. So only in the past 1 year, this topic has become very much blooming, both machine learning as well as AI, whatever these words, deep learning. These three words are frequently used by many people, irrespective of the domain to which they belong. So it is not no longer a cup of CSC. Machine learning is not belonging to CSC alone. It is going to be for all the departments, all the disciplines, even arts and science graduate, they are going to use it, right? So, but it was developed in the year 1975 itself. It is not that yesterday it was developed or in the year 2019 it was developed. It was not like that. The concept of machine learning and artificial intelligence very well came into picture in the year 1975, and Herbert Simon has done extensive research. He has put a lot of research papers. He has got Nobel Prize also. And that was the history behind the development of the machine learning. So what is learning? First we will define what is learning, and then we will define what is machine learning, right? Learning is any process by which a system improves performance from experience. Hope you will accept this statement. Okay, there's a very simple definition. Any system for that matter, it may be a human system, basically a human system. When we are improving the performance through experience, see, normally there is a telling that experience is a very good teacher. Yes or no, right? So we have all done our graduation, UG, PG, PhD, everything we are done. But when we go and teach a subject, when you teach a subject the first time, you may a little bit feel difficult. You may require the support of your seniors, or you may require the support of textbooks, Google material, research articles, everything. But when you teach the same subject second time, you'll be a little more feeling more confident. And again, when you teach the same subject, you are going to become a master after 3 or 4 times without referring anything. Just on a day, you can go and shoot any topic. You can talk on any topic, right? So that is what is experience. Experience is a very good teacher, learning through experience. Yes. As a result, our performance improves and we get satisfied. Now, what is machine learning? The same process we are going to do. We are again going to improve the performance of the system through experience, but with the help of a computer program. That's all. We are going to develop a computer program which will improve the performance of the system automatically. Please underline the keyword automatically. Okay, automatically improving the performance through the experience. What is experience here? Experience is nothing but prior data. What are the data related to that particular system? You have to accumulate the data. You have to collect the data. That data is going to serve as a experience for you, and through that you are going to improve the performance of the system by writing a simple algorithm or a simple computer program. Right? Hope you have understood what is machine learning is. Right. One of our friends told that machine learning is something similar to artificial intelligence. I appreciate the participant for your active participation, right? So when we think of artificial intelligence, see, both they go side by side, right? So it is like pen and paper. You cannot separate pen and paper. Okay, when there is a paper, if you have to use a pen to write something, otherwise there is no meaning in it, right? Similarly, we can have this machine learning and artificial intelligence. But machine learning is a part of artificial intelligence. It is not like you cannot tell that artificial intelligence is equal to machine learning. You cannot tell. Artificial intelligence is a broad area, right? Machine learning is a subset of it, where we now talk about deep learning. Now coming to speech recognition, that is another aspect. Lot of research is going on in speech recognition, converting text to speech, speech to text. All this process is going on. Encryption, cryptography, all these words you have heard if you are really good in CSC. Okay, and similarly vision, computer vision, you have heard of this. Image processing, for that also machine learning is very helpful. See, I will give you a simple example. You are a teacher, okay, you want to know the students' attendance in your class. You can use a simple face recognition algorithm, which is basically a artificial intelligence. You need not have to read the names of the students and take attendance. What you can do, as soon as you enter to the class, you can take a snapshot of the class, right, and feed it to a database. That database will be having already the set of students who will be sitting in your class. It will match one by one, and it will tell that roll number 20 is absent and roll number 50 is absent, rest all present. That's all. That is automated. That is automated. So this type of simple automations can be done, which will reduce the help of the human intervention, which will not involve much human intervention, and which will reduce the errors also. Okay, and similarly language processing, we call about NLP, neuro linguistic language processing. Okay, so classification, translation, data extraction. Translation is a very good example of this artificial intelligence. You are talking in English and it will be automatically decoded in Tamil, Marathi, Hindi, Gujarati, whatever language you want. Okay, so that type of, see, recently NPTEL has opened this platform. They have given internship for people who are good in translation. So of course machine learning can be applied there also, right? So we have number of such applications, and for optimization also, whenever you want to minimize something, whenever you want to maximize some features, some particular objective in your problem, again machine learning will serve the purpose for you, right? So artificial intelligence is a broad area. Machine learning is a subset of artificial intelligence. Okay, so is it convincing to you? Hope it is convincing to you, right? Now we will see what is machine learning. As I told, machine learning is a branch of AI, artificial intelligence, right? What? It is a discipline, it is an area of study which is concerned with design and development of algorithms. Okay, we are just going to develop some algorithm that will allow the computers to evolve the behavior based on empirical data. See, understand, see, very meaningful definition this is. Okay, we are going to design and develop an algorithm. We are going to write an algorithm. As a result, its behavior is what we call it as a performance, right? So yesterday the student was late to the class, today the student is on time to the class. That type of behavioral change happens, right? So that is what is improving the performance based on experience. Experience is nothing but your empirical data, which are nothing but statistical or numerical data, which can be obtained from some real-time databases. Suppose if you want to work on cancer diagnosis, okay, so there are different types of cancers, breast cancer coming to other thing. Okay, so what the doctor can do, if the doctor is having the sufficient data, he can give to a data analyst like some person who is good in machine learning, and they can develop an algorithm. So whenever a new patient comes, just by taking their laboratory samples, they will be able to predict what type of cancer they have, first whether they have cancer or not, if they have, what type. So all these things can be done by using machine learning, right? And an approach to automatically learn to recognize complex. This is a very important advantage of machine learning, right? So when compared to neural networks, of course, neural network is also a part of machine learning, but when you talk about machine learning, it actually came only after neural networks. Okay, so the complex patterns to recognize systems which are highly complex, having a complex behavior in nature, okay, which involves a lot of dynamics, which involves a lot of robustness, like our power system. Our power system is highly robust, highly dynamic, highly complicated, highly interconnected. Okay, so such things we can apply machine learning. So study of simple algorithms, computer algorithms that improve automatically through experience. So my dear friends, you can refer the book called Machine Learning by Tom Mitchell, which is published in the year 1997. This is a very good book which will help you to understand the basic concepts of machine learning. Other than that, lot of journals have been published in the area of machine learning. So these two I thought will be interesting to you as a beginner to understand the concepts of machine learning. Now I have a quiz for you, right? So participants, please read this quiz. What is machine learning? There are 4 choices given. You have to select any one choice. Either you unmute and tell your answer or put it in the chat box. Just take some 10 to 20 seconds, not more than that.
Answer is C, madam.
C. Okay.
Yes, madam.
Anybody else?
Option A, ma'am.
Very good, sir. May I know your good name?
Arul Kumar, ma'am.
Arul Kumar, so our own
Yes.
faculty. Okay, thank you, Arul Kumar, for giving the correct answer. The answer is A, sir. See, actually, when you see B and D is already ruled out because it is given manual programs. So you know that machine learning means it involves a computer in it. Okay, so obviously you may have a doubt with A and C. Why we have to go for A? See, already in the first slide introduction itself, I told automatically improving the performance. You should not involve the human intervention in that. If you involve human intervention, there is no concept of calling it as a machine learning. It will be called as human learning. Okay, it cannot be called as machine learning. So it should be an automatic acquisition of knowledge through use of computer programs. Okay, please understand. So the answer for this quiz is A, option A. Okay, answer is A, right. One more quiz for you. What is artificial intelligence? Please read it and answer. Don't be in a hurry to shoot up your answer. Take 10-20 seconds to think and answer.
C, ma'am. C.
I think Mariappan, sir. Am I correct?
Yes, ma'am.
No, our faculty only is answering. You are not allowing the
Ma'am,
participants.
that is different Arul Kumar. He is A, or I think from another college. I think the Arul Kumar who answered.
Okay, we'll also have the answers from participants. Any other participants? You want to put your answer for this? Please hurry up. Any other answers in the chat box?
Option B, ma'am. Programming with your own intelligence.
Okay, one of the faculty has given. Okay, fine. But the answer is C. Okay, my dear friends. See, why it is C? Putting your intelligence into computer, that is not possible. Okay, that is not artificial intelligence. See, you cannot put your intelligence into computer. That is not really, see, even though the artificial intelligence is blooming, it cannot replace human intelligence. Okay, humans are really, see, today we get a work. So you are all in teaching profession. Today you get a work, immediately you do it and you submit to your HOD. Immediately you complete the task and submit to the principal. See, such types of crisis cannot be handled by machine unless otherwise you program the machine. So it is not putting your intelligence into computer, or it is not programming with your own intelligence. See, you cannot program the computer with your own intelligence, because computer has a syntax. Computer program needs to follow certain hard and fast rules which you have to adapt to it. Okay, and playing a game, that is not basically what is artificial intelligence is. So the answer for this is making a machine intelligent. Making a machine intelligent, making a machine to perform the operations of a human being intelligently. So that is what is artificial intelligence, right? So the option or the answer for this quiz 2 is answer C, making a machine intelligent. Hope the answers you are able to understand why this particular answer is there for this particular question. So now we have understood what is machine learning and what is artificial. Any other questions? Any other participants?
Ma'am, in case of unsupervised learning, the answer is C, ma'am. But in case of supervised learning, I think the option is B.
No,
Is it, ma'am?
even though it is a supervised learning, my dear Arul Kumar, it involves lot of programming syntax which need to be followed. See, there is a restriction for that. If you are going to apply some technique called neural network has step 1, step 2, step 3, which you have to follow. Okay, so you cannot include whatever you think in that. So you can make your system flexible, or you can develop your own algorithm. That is something different. But even then, it is not programming with your own intelligence. So it will not come in that aspect. Whether it is a supervised or unsupervised, it is making a machine intelligent to work. Right?
Okay.
Is it okay, Arul Kumar?
Okay, ma'am.
Okay. Now, why machine learning? Having understood what is machine learning, why machine learning? So we need to develop systems that should be having the capability to automatically adapt themselves. Okay, see, now we are talking about smart grid. When we talk about smart grid, we are calling a term called self-healing. If some problem occurs, somebody should not come and solve the problem. The system should be self-reliant to solve that particular problem which it faces. Okay, so automatically adapt and customize themselves to the individual users. Example is mail filter. It's a very good example, very popular example, available in all textbooks. Whenever you see any textbook, this example will be there. Okay, so your mail is coming to your inbox. If you have written a machine learning algorithm and if you have fed it into it, it will, based upon the mail, you can see whether it is a SAMP mail or not SAMP mail. Okay, whether that mail is really required to you or not required. See, a lot of mails will be coming unnecessary. We'll be wasting time to see what is the mail. Okay, so you can divide everything. You can if you have, that is called, what is called as classification. If I get mail from my own colleagues, it will be treated as priority 1. If I get mail from external people, it will be treated as priority 2, or something like that. Whatever you think of, you can design your algorithm and program in such a way, right? Discover new knowledge from large databases. See, there are a lot of data, there are a lot of junk data available everywhere. Wherever you see, there are a lot of data. See, take the example of our students' data. See, if you want to predict, you want to predict which students are aspiring to come for engineering. Okay, what type of category students, whether urban students or rural students. This is the question for you. So what you will do, you will take the past 5 years or 6 years data, and you will from the database which is available in Google, you can find out how many students from rural have joined engineering, how many students from urban have joined in each year. You have a bar chart with you with proper data. Based on that, you can write an algorithm and you can predict in the next 5 years what will be the trend, from which category students will be coming to pursue engineering or to pursue medical, something like that. That is what is discovering some knowledge from the database. So example, market-based analysis, what we now go with COVID data. Okay, you are using that Arogya Setu app, everybody is using. There is a machine learning algorithm in it. Okay, in Arogya Setu app, what you are using, it is automatically updating the data every day. Now recently they have added one more feature. Okay, initially there were only 3 features: recovered, so much people identified, recovered, and then deceased. Now one more feature also, some active they have added. So all this is possible only through machine learning algorithm. Okay, develop systems that are difficult and expensive. That is very important. Certain systems are highly difficult. See, for example, you want to do an operation for a patient, heart transplantation, which requires 12 hours. Can a doctor stand 12 hours in an operation theater and do the operation? Will not the doctor faint? Will not, that will be a serious thing for the patient. The patient will die, right? So we have to make such things automated, okay? Because we cannot take for risk. And so those things are certain things are highly expensive. So I'm talking about difficult category. Similarly, certain things are highly expensive. For that also, we can go for machine learning algorithm. Right, why now? Why now? Why the scenario of machine learning to be used now? Large voluminous data is available everywhere, but no knowledge is acquired from the data. See, data and information is available plenty. Okay, but we have to get some inference from the data. If you want to get it, you have to apply such algorithms. Growing progress in available algorithms, increasing support. This is very important. Now when you write a project proposal and if you put just machine learning, using machine learning algorithm, I'm damn sure that you will get that project fund sanctioned. Okay, because you are getting a lot of support from the research laboratories and industries towards the concept of machine learning. So that is the hot area today which has motivated machine learning to be a blooming area. Concept of learning in the ML system, machine learning system. See, already I told learning is improving the experience at some task. So you have three important words here: task T, performance measure P, experience E. Okay, take this example again. I'm categorizing a mail, whatever mail is coming to my inbox, I'm taking it as either a spam mail or a not spam. Okay, it's all spam is what is all the mail the user does not want to receive and has not asked to receive. In whatever mail we don't want to see, we put it in the spam. Whatever mail we want to see, we put it in the non-spam or HAMP mails. Okay, so what is T? T is the task. What is the T? Identify the spam mails. Okay, identify a new mail, whether it is a spam or not. That is the task. Task is nothing but what to be done. Okay, what is the performance measure? How will you see that your algorithm is working fine or not? Percentage of the spam mails that were filtered, percentage of non-spam mails that were incorrectly filtered out. Okay, that is a misclassification accuracy. Suppose if you have 100 mails, 90 mails are correct, are classified correctly. Remaining 10 mails are wrongly classified. It is actually not a swamp, but it goes to swamp. It is important mail, but it has gone to swamp. So that means there is an error in your algorithm. You have to rework on your algorithm. So the performance is purely based on the classification accuracy and based on the experience. That is the database of emails that were labeled by the user. See, this E has a lot of role to play. See, data is very important. When you give a wrong data, the data should cover the entire spectrum of operating conditions. Okay. For example, if you see again, I'm going back to the example of understanding a rural student data and urban student data and seeing whether they pursue engineering or not. Suppose if I take the data only from Madurai and Virudhunagar, my algorithm will not work fine. I have to take the data across Tamil Nadu, at least across all the districts, and then come to a conclusion. So the data should cover the entire spectrum. It should not address one particular region. Then your algorithm will not be a generalized one. It will become a specific one. Okay. So the box here tells the database training set. You should have a good amount of data and the learner is your algorithm. And here you have the model ready to be implemented in real time. Now this has another important advantage. Now we go for hardware implementation. So you have all heard of FPGA. Okay. So in FPGA, we can very well implement this machine learning algorithm. It's a simple coding only. It's a simple programming code. So you can just deploy that code in FPGA and you can go for real-time implementation and real-time control. Again, a quiz for you. Which of the following statements is not true? Please read carefully. Don't be in a hurry. So the question is, which of the following statement is not true?
Option D, man.
Good, sir. This is the answer. Okay. You cannot tell that artificial intelligence is different from machine learning. Artificial intelligence is the major domain. Machine learning is a part of artificial intelligence. You cannot tell, both are completely different. Okay, 1 and 3, I think you can understand. A and C already know, we have seen through definitions. Data redundancy affects, no, data redundancy does not affect the performance of ML. See, when you have a repeated data, it will filter automatically. It will take only the unique data. So that is the advantage of machine learning when compared to neural network. Whereas data redundancy sometimes will affect the performance of neural network. Okay. So thank you, sir, for giving the correct answer. Learning process in the machine learning system. This you have to very well understand. How learning happens inside a machine learning. What is the black box inside it? Okay. So here you are seeing the real world. You are having some data which is existing in the real world. It may be any data. It may be smart grid data. See, yesterday in the evening, Sir was handling a lab session, Dr. Prince sir. He was telling about the battery charging analysis using neural network. The same thing can be done using a machine learning algorithm also. So he showed some Excel data. So that data you can think of. Okay. So through sensors, through cameras, through some Google database, you are collecting data. What is the first step? Pre-processing. I will tell you in detail what it is. This is the first step, pre-processing. You have to first, you have to first rearrange or rework on the data properly before going to applying to the algorithm. It is something like that. See, before you go to kitchen to cook, you have to clean everything properly. Then only you can start the cooking. If you finish the dinner cooking, before starting the next day, the night your mother or your wife or whoever it is, lady who are there in the house, they will clean everything and keep it. It is something like that. Filter and clean everything and keep the data ready for implementation. That is what is called pre-processing. And dimensionality reduction. This also I will talk about in the later slides. Okay, it is reducing the number of input variables which is used in the process of the algorithm. Then model learning. Model learning is only called as the developing the algorithm or writing that computer program. And finally, you are doing the testing of the model and you are validating whether the model is working fine or not. Okay. So here you are having the classification, regression, clustering, all the algorithms. So this is the main heart. Model learning is the main heart of your system. Okay. Now take this example of that email example which we have seen. So what will be the measuring device? Email server. Okay. So email server, lot of emails will come to the email server. Okay. What is the pre-processing? Whatever the things we can use, number of recipients, size of the image, all this we can take. Number of attachments, number of reply mails will come, no, that one. Number of reads in the subject line. So these inputs we can use in the pre-processing for filtering the data. Okay. Now see this data set. This is a simple data set, a small tabular column shown here. So here it is giving the length of the email in some kilobytes or whatever it is. Okay. And the country name is given. So one email is from Germany, one email is from Nigeria, one email is from USA. From that server it has come. Okay. And what is a customer type? See, this is like some call center or some type of organization. Okay. So the customer type from Germany, they have got two mail, one from a gold customer, gold category customer, silver category customer. See, based upon these input, we are classifying it as either not swamp or HAMP and swamp mail. So this is a simple database we are having. These are numerical data. This is nominal because it is the words. Okay. What is ordinal? Ordinal is nothing but it is also a category type, but it will be in an order. It will be in an order. Say 1, 2, 3, some order. It will follow a unique order. Like if you use colors, RGB, red, green, blue. So such types of data are called ordinal data. Again a quiz for you. A feature F1 can take a certain value. Feature F1 is some particular variable, okay, can take a certain value A, B, C, D, E and F and represents the grade of students, A grade students, B grade, C grade, D grade, something like that. Which of the following statement is true in the following case? Whether the feature is a nominal variable or an ordinal variable or not anything or both of these. Yes, answer please. Don't worry, you will not be given marks for these questions and answers. Yes, please. See, you tell some answer, yeah, there are only 4 options. Why do you worry? See, if it is in a classroom, we will know who is telling. Now we don't know who is telling also. Just make a guess. Hello, my dear participants.
B, ma'am.
Yeah, B is the correct answer. Thank you, participant. So definitely C and D will not come. It does not belong to any or both of this is not possible. It will belong to any one only. Okay. So the confusion may be either in A or B, but as I already told, ordinal variable means it should follow an order. Okay, say A is best, B is somewhat better, something like that. Okay, so A is the highest grade, B is the next grade, C is the next grade. So it follows an order. So hence feature F1 is called an ordinal variable. Thank you, gentlemen. Now, before going into the detailed discussion of that pre-processing and other things, let me introduce a simple linear classifier algorithm, which is a two-dimensional model, assuming that there are only 2 attributes. Okay, so what are the 2 attributes? X-axis tells new recipients. New recipients means new mail. Number 1, number 2, number 3, some new mail. Y-axis tells email length. Okay, so what I'm going to do, I am getting a mail and I am seeing the length of the mail. With that, I am telling whether there is a swamp mail or not a swamp. Okay, so maybe you can call blue color as a not swamp mail and red color as a swamp mail, which is not needed by me. Suppose you see the first picture. Here, the data are clearly, they settle themselves in a clear space. Here the data, here all the blue, they are close to each other, all the red is close to each other. So you can simply draw a line separating this blue and red. This is what is called linear classifier. Okay, so you are just finding the boundary between the 2 different classes. Simple straight line boundary you are finding. That is called linear classifier. Now come to the second picture. Here you can see this line need not be like this. See, it's just a guess. Okay, through trial and error. It can be like this, a lot of lines are there. It can be any one. Any of these would be fine. But which is best? Coming here. Okay, here when you put a line like this, there are 2 errors. See, one red should come here, but it has gone there. Similarly, blue also has should be here, it has gone here. That is, we have 2 errors here. 2 samples are misclassified in this particular classification, 2-dimensional problem. 2 particular samples are misclassified. That is 2 errors. Whereas when you put a border line like this, boundary line like this, which is irregular, this is called a non-linear classifier. This is called non-linear classifier. See, this linear classifier you can represent by a simple straight line equation, y equal to mx plus c. Okay, by using that you can find the equation. Once the equation is found, whenever a new x comes, you can find the new y and tell that it belongs to swamp or not swamp. But here it is going to be a non-linear. That means it is going to be a polynomial function or even more complicated function with a lot of x squared, x power 3, x power 5, something like that. So such type of things are called non-linear classifier. Okay. So, but it is always, if you want, you can go for linear classification, non-linear. Anything you can go, it is up to you. You just have to see the accuracy. If the accuracy is 98%, you can feel happy with a linear classifier. If the accuracy is only 40%, you have to go for applying a non-linear classifier and see whether the performance and the accuracy improves. Okay, but instead of restricting to a single straight line, if you have a small margin, okay, it will be better. Okay, so this margin is called soft margin. The maximum margin linear classifier is a linear classifier with the maximum margin. Okay, this is the simplest kind of SVM. The later slides I will tell you what about SVM, support vector mission. So this is basically an example of linear SVM. Instead of having a single straight line, you can have a small margin so that these whatever points or samples touch this margin, they are called support vectors. They are called support vectors. They only help in classifying whether it is a swamp mail or a not swamp mail. That is, few of the samples itself act as the support vectors, which will later help in the process of classification. So compared to this, this is like accurate. Okay, see, when you use machine learning and neural networks such algorithm, there must be some amount of vagueness. It is not possible to get 100% accuracy. If you tell 100% accuracy, then you are bluffing something. Okay, it's not possible to get 100% accuracy in a machine learning algorithm. Non-linearly separable case, that is what is first case is linearly separable. Okay, linearly we are splitting the samples. The second figure and the third figure belongs to non-linearly separable. So here it is highly irregular in shape. Here it is coming in the form of a circle. So the equation for classification will be a circle. See, all these machine learning algorithms has a mathematics behind it. Nothing can evolve without mathematics in this world. Okay, so it has a basic optimization technique and simple equations behind this algorithm. How will you evaluate the performance of a model? First, we have to randomly select a portion of data to be used for training. See, whenever you have a lump of data set, okay, first you understand you have a large data set, say 1 lakh data you are having. You are having 1 lakh data. See, one of my research scholars doing research on energy metering. What is that data? She will be without putting a sensor in each and every appliance. See, in our home we are having fan, tube light, AC, refrigerator, TV, radio, etc., etc., laptop, dryer, washing machine. So without putting a sensor, yes, am I audible? Okay, I'm audible now. Hello.
Yes, ma'am. Yes, ma'am. Continue.
Okay, fine. So without putting a sensor in each and every appliance, just by capturing the energy meter waveform, the output energy consumption waveform, she will be able to predict at what time which appliance has consumed the power. Okay, accordingly we can see how to reduce the power consumption. What will be the priority of switching on or switching off the appliances? All these predictions we can make. For that, she is using machine learning algorithm. A very simple example. Okay, so when you have a large data set, say 1 lakh data she is having, of all 1 lakh data is 1 lakh house data. Okay, so she has to select which are the training data and which are the testing data. So normal practice is you have to use 75% to 80% of the data, total data should be allotted for training, and the remaining 20% to 25% of the data should be used for testing. This is the normal thing. Whenever you refer any research paper, they will tell like this only. Okay, so this you can keep it in your mind. So train the model. What you have to do? You have selected the data, you have gathered the data, you have split it into training and training. Just to train the model on the training set. Once the model is trained, you have to test using the test set. Okay, why we have to test? Because test set are unseen data. See, you have trained the model subjected to the training set. So the model has seen the training set. It is something like that. I will give you an example. In your house, your mother is there, your father is there, grandfather is there, wife is there, husband is there. All these faces are familiar to you. Somebody after 10 years come to your house. You may ask, who is this? He is our Peripa, he is our Perima. Like that your mother or father will tell. It is something like that. So unseen data is seeing a stranger. Okay. So the model is exhibited to a stranger. It should be able to classify it properly. So when it is able to classify the tested data properly, then that means your model is trained properly. Okay. So you have to tell the accuracy of your model not based on the training set, but based on the test set. Okay. And as a result, you will arrive at a matrix called confusion matrix. What is this confusion matrix? You have two categories. Okay. Blue color and red color. Number of blues wrongly classified as red. Number of red wrongly classified as blue. That is what is called misclassification. Blue is correct one. Red is correct one. You can see this matrix. See this half diagonal values. Diagonal values are correct. Half diagonal values will tell you the misclassification. If the half diagonal, everything is 0 in half diagonal, that means your classification accuracy is 100%. Now there is 1. So obviously your classification accuracy may be something 98%. Okay. What are the various types of machine learning algorithm? Already I introduced in the introduction section. Okay, supervised, unsupervised reinforcement. There is another new terminology is coming into picture nowadays: deep learning and deep reinforcement learning. However, these three I will not touch. Okay, if I want to talk about all this, then I need one more day. Okay, it is very difficult to do. So I am going to touch only upon the supervised and unsupervised learning. Okay, what is supervised? You have either classification or regression. So classification means output is a discrete one, 0, 1, like that. It is a discrete one, known. Okay, known, unknown, swamp, not swamp, like that. Whereas if the output is a continuous one, continuous means weather forecasting. So in weather forecasting, today the weather is 34 degrees Celsius, tomorrow 35. That is the continuous data. It is not a discrete data. Okay, suppose if I tell sunny or not sunny days. Okay, it's a sunny day. Yes, sir.
Ma'am, there is some disturbance. Ma'am,
Disturbance.
there is some disturbance, ma'am. Somebody has unmuted, I think.
Okay. I don't know who has unmuted. Okay. Now is it okay, Mariavan sir?
Now okay.
Okay. So output as continuous means it is regression. Okay. If the same thing, if you do it as a whether it is a summer day or a winter day, then it becomes classification. The same weather forecasting, you do it either as a summer day or a winter day. If you classify like that, it is becoming a classification problem. If you predict the temperature, that is going to be a regression problem. So these are the 5 algorithms which I listed in the previous slide. Supervised learning means it generates a function that maps input to the desired output. Okay, so you are having the input data as well as the output data. You are mapping the input to the output. It is something like, if this is the input, this is the output. If input is X, output is Z. If input is X2, output is Z2. Like that you are classifying. That is, both input and output are known. That type of learning is called supervised learning. It is like learning in the presence of a teacher. Okay, in the classroom you are learning, no? The students are learning in the presence, in your presence. That is called supervised learning. In the home they are reading, no? That is called unsupervised learning. Okay, so they are learning, we don't know what they are learning. Whatever problem they solve, we don't know whether they are correctly solving or not. But they learn from some raw data without knowing the output. That is called unsupervised learning. Semi-supervised, part of learning will happen in supervised mode and part of learning will happen in unsupervised mode. It is like called semi-supervised learning. Okay, but normally we don't use this algorithm because it has not given much popularity or not gained much popularity and not given much accuracy in various real-time applications. Now reinforcement learning, it learns how to act given an observation of the world. See, it is an agent-based learning. An agent interacts with the environment and watches the results of the interaction. The environment provides feedback in the form of rewards. Okay, so you will be having a rewarding feature here in a reinforcement learning. It is subjected to the environment and the environment will provide a feedback in the form of rewards. Okay, that is what is called reinforcement learning. Deep learning is also called as deep structured learning, which uses multiple layers to progressively extract higher level features from raw input data and make decisions. Okay, so very complicated problems having number of data attributes, number of input attributes, higher level features. Okay, such types of things we can go and apply the deep learning algorithms. Again, a quiz for you. In classification algorithm, output or target vector is either discrete or continuous. Yes, participants. If somebody has answered in chat box, please let me know.
Discrete word.
Very good. So the answer is discrete and the answer is also discrete. Thank you. You're all active, you're not sleeping post lunch. So the main difference, the people nowadays, they have started using deep learning, but they should understand the difference between machine learning and deep learning. So machine learning uses algorithms to parse data, learn from the data, and make informed decisions based on what it has learned. Okay, so based on the data you are subjecting, it will make the decisions. Deep learning algorithms in layers to create an artificial neural network that can learn and make intelligent decisions. See, here, even though the data is not correct, in deep learning, if the data involves lot of noise, lot of flaws, okay, if the data involves lot of errors, even then the deep learning will be able to do better because it makes intelligent decisions. Whereas machine learning performance is purely based on the data what you are giving. Okay, so pre-processing plays a vital role in machine learning. What are the various ML approaches? Decision tree, which is very popularly used, which is a simple if-else statement based algorithm. Okay, I'll talk about decision tree in detail. Associate rule learning, this is not much used. A method for discovering interesting relations between the variables in large database. There may be some interesting relations. This will be very well used in medical diagnosis field. Okay, people will tell, doctors will tell, enna vyadine theriyala. They will tell like that. Okay, such type of disease we have never come across. The patient or lab samples, when we test, it is something different. Some interesting behavior if you want to come out, then it is called associate rule learning algorithm. Okay, ANN, already you know about ANN. It is a simple computational model or a mathematical model which will simulate a system. A structure will be simulated based upon the biological neural network behavior, and as a result, we will be able to predict the relationship between the inputs and the outputs. Genetic programming, it is an evolutionary algorithm. It is purely an optimization algorithm, which is also inspired by our own biological gene behavior. Chromosomes, whatever we talk about. From that, we have developed the algorithm called genetic algorithm. It is a machine learning technique used to optimize a population according to a fitness landscape. Okay, so you are going to do some minimization, maximization subject to some constraints. If you have a problem like that, you can go for genetic programming. Inductive logic programming, it is an approach to rule learning using logic programming as a uniform representation for examples. Okay, so it is like a rule based learning. For example, your fuzzy logic. Okay, you have all heard about fuzzy logic. It is based upon some rules, fuzzy if then rules. If you use such type of expert system for your application, we can call it as an inductive logic programming. Now, support vector machine, that also I will discuss in detail. And clustering and cluster analysis. Clustering is nothing but grouping the data into various clusters, like what we saw. In a class of 60 students, I am grading the students. A category, very good students. B category, average students. C category, below average students. I have a lot of data to classify, starting from their financial background, starting from their whether they are first graduate, whether what is their school marks, which background, which place they hail from, what are the marks they have secured, whether they belong to Tamil medium, English medium, like that. I may have n number of input data to finally classify as a good student, average student, and below average student. Okay, so and Bayesian network, it is a probabilistic approach which you have seen the normal distribution curve. Okay, so it is based upon that probabilistic distribution Bayesian. So we have a classifier called Navy based classifier. You can Google it and you can study Navy based classifier. It is purely a conventional classifier which is based on the probabilistic graphical model. And reinforcement learning I have already introduced to you. Applications of ML. ML has wide number of applications. Okay, as I already told, starting from language translation, medical diagnosis, market analysis, online fraud detection. Okay, in banking sectors, we can go for ML applications, virtual personal assistant, emailing, filtering emails, self-driving cars. That is what is, you can think about e-vehicles, product recommendations, traffic prediction, how the traffic will be in Chennai after 10 years, how this locality is going to improve after 10 years. All this you can predict. Okay, speech recognition, image. So there are n number of applications. So I have just recently referred this URL. If possible, I will show you at the end of the session, and this PPT also will be shared to you on the last day of the session. You can go to this URL, my dear participants. This will be very much useful for your students. You can refer a lot of interview questions are there for machine learning. So really, if your student is interested to go for a job which involves the expertise in machine learning, they can study this. And before they face the interview, like in Infosys, Tata Consultancy, or some IT companies like that. Okay, so you can use this for your students. Okay, there is a quiz. Can you name any two ML approaches popularly used for real-time applications? You can put it in the chat box, or you can unmute and tell. Answers? See, now just I've introduced a lot of approaches. Any answers? Even one approach you can tell. Okay, I think participants have put it in the chat box. And Agdev ma'am, can you tell me what is the answer they have put in the chat box?
One of the professor Karthikeyan sir has told decision tree learning.
Okay.
And one of the ma'am Meshina V has said fingerprint unlock, face unlock.
Okay.
And one of our professor Shilaja has said pattern recognition.
Okay. Okay.
And another one professor has answered video surveillance, social media resources, ma'am.
Okay, okay. So I think good for their participation. See, this video surveillance and all will come in the application part, but approach if you take decision tree is a very good approach. And similarly, support vector mission is there. Pattern recognition is the entire thing. Machine learning is one particular box in the pattern recognition algorithm. Again, one quiz. In ML context, learning under the presence of a teacher is called as?
Supervised learning.
Okay, supervised. Thank you, sir. Thank you very much. So answer is C. What are the important steps to solve? As I already told, data gathering, data processing, feature engineering or feature selection. And see, what is data processing? Pre-processing, cleaning the data to have homogeneity. Okay, and making your data more useful, that is called feature engineering. Algorithm selection is selecting the right model for the right application and evaluating the model. So we'll go one by one. Another 5 minutes I will take, then we can have a break. Okay. So data generation or pattern generation of each and every state of the system is called a pattern. Okay. So when you identify your data, you have to put it in the form of a matrix, which will be having like x1, x2, etc. to xn. x1 is column 1, x2 is column 2, and so on. Every row indicates a sample, and you'll have a simple matrix, some m cross m matrix, where m denotes the number of samples and n denotes the number of features or the number of input variables. Okay. For example, if you want to predict the COVID data, you want to work a machine learning algorithm on COVID data, you can take some features like age. Age can be one particular x1. Second thing, you can take past history of that particular patient, whether they are having some diabetic, some past history, something like that, and the place where they reside, maybe the x3, something like that. So x1, x2, x3. Based on that, you can tell whether that patient is prone to have COVID or not. Okay, so like you can predict like that. And the data patterns needed for training and testing can be obtained either through online mode, through direct sensors. You can put the sensors to data acquisition system. You can directly capture the data on online mode, for example, like metering data. Okay, or you can take it from offline simulations. You can work in the laboratory, you can collect the data and store it in some plotters, and later on you can use it for your machine learning algorithm. Train set must contain, remember this is very important, must contain all the significant operating points which is pertaining to different category of classes. Okay, so training set is with the selection and the data in the training set is very important for the accuracy of or the generalization ability of any machine learning algorithm. Data pre-processing, it is important in all the data mining and machine learning projects. What is data pre-processing? Cleaning, normalizing and filtering the noisy or unreliable data. Data which is not reliable, which will not be ready-made to use. We have to filter it. So data normalization or data scaling, it is otherwise known as data scaling. And in many real-world problems, if you see, the attribute variables have values with different dynamic ranges. That is a problem. So when you take temperature, it may range from say 0 degree to 40 degrees Celsius. But when you take pressure, it may have a different range. So like that, some will be in 2 digit, some will be in 4 digit, some will be in 6 digit. So, and the data is going to have different ranges. If you subject the data as it is to your machine learning algorithm, it will think that data which is having more digits is more important and data which is having less number of digits is less important, and it will accordingly put it in the, it will accordingly tune its algorithm, and it will as a result give a wrong answer. Okay, so this should be avoided. In order to overcome that, we are going for normalizing the data and bringing all the data into a common range. So it is a form of data transformation which involves rescaling of the attributes. As a result, data samples are scaled to fall within a small specified range. Okay. So very popularly used data normalization algorithm. Min-max algorithm, Z-score and normalization by decision scaling. So the first one, it is very popularly used. I have used for my research only the first one. So performs a linear transformation. It is like a linear transformation. See, the data is just scaled to either -1 to 1 range or 0 to 1. That depends upon you. Suppose if you feel that having a negative data for that particular variable is meaningless, then you should scale for 0 to 1. If you take temperature, having a negative value is meaningless, because in a country like India, in a place like Tamil Nadu, we cannot have less than 0 degrees Celsius. Okay, so whereas in Kashmir or some other cool places, it may even go to negative degree. So it all depends upon the perspective of the people and the application, the requirement needed for that particular application. So this is the simple formula. So very simple. Each data you have to take the old value of the data. What is the old minimum value for every particular row? I told no. For every particular row is a sample. Every particular column is a variable. For every column you find the minimum value and maximum value. That is called min volt and max volt. Hope you understand. You just find the minimum value in the particular column 1. Call it as min volt. Maximum value, call it as max volt. What is a min nu and max nu? Min nu may be -1 if the range is -1 to 1. Max nu will be 1. So having this, just substitute, write a simple code, it will give you the result. Okay, Z-score normalization is based on the mean and variance of the data. This also you understand very clearly. Decimal scaling is nothing but dividing the data by some 10 power something. 10 power 2, 10 power 3, 10 power 5, C is any integer. Okay, suppose the range of the attribute is -500 to 45. The maximum absolute value is what? 500. So what I do, I take some 10 power nearer to 500. So nearer to 500 means it may be 1000. So I divide 500 by 1000. So my range is now reduced to, from -500 to 45, it is reduced to -0.5 to 0.045. This is my range. So I have scaled my data. I think with this we can go for break. Is it okay?
Yes, ma'am.
Okay. We'll continue after a short 5 or 10 minutes break.
Dear professors, let us break for a short break of 10 minutes.
Nothing refreshes like a cup of tea. Welcome back, participants, to the next session of knowledge gathering with Dr. S. Kalyani ma'am. Ma'am, please.
Yeah, thank you. So before break, we were discussing about the basic concept of machine learning. What is machine learning? Why machine learning? How machine learning? And then we have seen about the different stages of machine learning, in which we have touched upon the stage 1, which is called data pre-processing. Now we will talk about the remaining 2 important stages. One is called the feature engineering or feature selection stage, and third one is the classifier design stage. So what is feature engineering or feature selection, right? So it is a technique of dimensionality reduction. So what is this dimensionality reduction? See, you have a particular problem, a real-time problem having some 10 or 20 features, 10 or 20 attributes. Remember, I told about the data set generation. It should be in the matrix form, where row indicates the sample and column indicates the variable. So you were having x1, x2 up to xn. So totally you had x1 to xn. There is n number of variables for your problem. Now assume n is 100. So having 100 variables for a real-time problem. So if the variables are 100 and the samples are 1 lakh, so what will be the size of the matrix? 1 lakh into 100. So imagine the number of elements. Okay, so it is highly cumbersome, and when you feed it to a computer program, sometimes there may be some memory problem, or the complexity of the algorithm itself will increase when the number of variables are very large. So we have to reduce it. That is what is the process of feature engineering. So we are going to select the important variables alone. We are going to reduce that 100 variables to some 10 or 20. With the 10 or 20, we should be able to obtain a good accuracy. Okay, so it is called feature selection. So feature selection is also known as variable selection or feature reduction or attribute selection. So there are a lot of names given to it. It is a process of selecting a subset of original features. So you have original features. I am taking a subset of original features, removing the redundant and irrelevant features. What are irrelevant? For example, if you take an electrical system, you have current, voltage, power. All the 3 are interrelated. It is not necessary to have all the 3. You can have 1 or 2. That is enough. It is more or less related. Voltage and current is related to power. So you can remove the variable called power, something like that. Okay. You have speed, torque. Both are interrelated or something. You can remove one variable. So like that, you have to see that you need not have to study by inspection until you just feed the raw data to the feature selection algorithm. It will predict which are the important variables, what are the non-important variables. So X, we initially had the matrix X. Now that matrix size is reduced to Z, where we will be having Z1 to Zm. Okay, so n number of features is now reduced to m number of features, and we rename the matrix X as a Z matrix. Now Z matrix will be the input data for your classifier or the machine learning algorithm. Remember, m should be smaller than n. M and n being the number of components in the feature vector and pattern vector respectively. So the importance of feature selection is to reduce the curse of dimensionality and the space, search space. If the search space is very large, it is very difficult to get the optimal solution. Okay, features must be easily computed, robust, and insensitive to disturbances. What are the various feature selection algorithms available? There are n number of algorithms available, but all the algorithms are basically classified into 2 models, filter models and wrapper models. What is a filter model? What is the difference, or what is the basic definition? When in filter model, we use a ranking criteria to identify which feature ranks first. Okay, so based upon a ranking criteria, if we identify the important features or important variables, that is called filter model. If you use a search algorithm, you just undergo a search algorithm through the search space, and based on that, if you identify the important features, then it is a wrapper model. So in wrapper model is similar to an optimization algorithm which involves an objective function. What is the objective function? Objective function is minimize the number of features subject to classification accuracy. So that type of model is called wrapper model, but it has been researched in various research articles, and it has been identified that wrapper model is much better when compared to filter model. In my own research also, I have used all these algorithms, whatever is listed in the types of filter models and wrapper model, and I identified that sequential search algorithm is the best algorithm for my research problem, which is a power system security assessment. The next third stage is algorithm selection and training. So data generation is over, data pre-processing is over, feature selection is over. Okay. So then what is the next stage? We have to select which algorithm we have to use, thereby train the input data and thereby develop the ML model. So you have the supervised, unsupervised, and reinforcement. So these are the various algorithms which is listed in this particular slide. Very commonly used algorithm is support vector mission, decision tree, k nearest neighbor, and neural network. Now we go for deep learning. Deep learning is nothing but it is a neural network architecture only. And model testing. You have to test the model. So once you have two phases here, training phase and prediction phase. In training phase, you are getting the features, you are applying to the model, you are training the model, and you are keeping it ready. But in the prediction phase, you have to give an unknown samples, which is called the test set, and for that unknown set, you select only the variables pertaining to the selected features or the values pertaining to the selected features and give it to the trained classifier. Finally, you will get the output. That is a label, whether it belongs to category 1, category 2, category 3, and so on. It may be a binary classification problem or multi-classification problem. Can you name any one data normalization technique and feature selection algorithm? So far we have seen many data normalization technique, 3 types we have seen. Feature selection also, many algorithm is there. So can you name any one? You can put your answers in the chat box. If any answers is there, Renu, kindly let me know.
Minimum maximum normalization.
Yeah, any one technique. Hello. Hello. Any answers from any participants? Renu, can you tell me any answers in the chat box?
Yes, ma'am. Actually, Karthikeyan sir has replied like min-max.
Okay.
And Arul Kumar sir has made like linear scaling or log scaling.
Okay. Thank you very much. And feature selection, you can think of filter model or vapor model. Okay. Thank you. Now coming to the very important thing. Okay, classifier algorithms, basically supervised and unsupervised. So in my research, I did my research in the period 2011 I completed, right? So I have applied all these algorithms to my data set, KNN, base, LS, all this I have applied. So I have taken this diagram, most of the content are from my thesis only. So conventional classifiers, neural network classifiers, machine learning classifiers, and clustering technique. Clustering is basically the unsupervised learning features. Okay, so these are all the algorithms I've used, but I cannot explain each and everything because time will not permit me. So I'm going to take one from each. So I'm going to explain about KNN because KNN, K nearest neighbor, very popularly used conventional classifier. I'm going to explain one neural network classifier, which is the basic classifier, multi-layer perceptron, MLP. I will explain to you machine learning classifier, 2 types I will explain, SVM and DT. There is support vector mission and decision tree, and clustering I will talk about k-means. So these are the 5 algorithms which I am going to talk about, and these are the 5 algorithms which are very popularly used for many real-time applications in machine learning. One by one we will see. First one is k nearest neighbor. What is k nearest neighbor? Okay, what that k indicates? K is a simple integer number. Okay, see, you have number of data samples belonging to class 1, class 2, class 3, or a maximum we have 4 classes, assume. Okay, so it is an instant based learning. Instance is nothing but data. Every data is called an instance. Okay, because every data is captured at one particular time. So only it is called as instant based learning algorithm for classifying the objects based on the closest training examples in the feature space. See, we are having two important search space. One is called input space, another one is called feature space. What is input space? When you take the data as it is and when you plot it in a 3-dimensional or a multi-dimensional view, it is called input space. When you give that input data to your feature selection algorithm, your dimension of the problem reduces. Instead of having a 10 dimension, it becomes 4 dimensions. Okay, in that aspect, your input space is reduced to feature space, right? So that is what you have to understand the terminology. The k nearest neighbor classification rule consists of determining k nearest neighbor to the unseen sample x. So I'm subjecting the algorithm to a new sample called x. Okay, and I'm identifying what are the various other samples which is nearer to x. So the other samples which is nearer to x is called k nearest neighbor. I can fix that. I can fix k as 2. I can fix k as 3. That means if I fix k as 3, it will identify 3 nearest neighbors to the unseen sample, and it will see what are those 3 samples to which category it belongs. Class 1, class 2, or class 3. Suppose if I take k equal to 10, assume k equal to 10, 10 nearest neighbors to the unseen sample x. So what will happen? Among the 10, 5 belong to class 1, 3 belongs to class 2, another 2 belongs to class 3. So which is highest? 5 is highest. That means 5 number of samples belongs to class 1, that is having the majority vote. So automatically x will be labeled to class 1. Hope you understand this. Okay, so determining the number of nearest samples to the particular unseen sample, and later on, based upon the voting principle, we will assign the class label for the new sample called x. Okay, so this is the simple concept behind this k nearest neighbor. Very simple algorithm. In MATLAB, you have a single function. See, we extensively use MATLAB for all the techniques, whatever we use in machine learning algorithm. There is no need to use any others. There are a lot of softwares available for each and every tool. There may be one software, but MATLAB comprises everything. All the tools can be implemented in MATLAB. Therefore, in the evening session, we are having 8 to 9, we are having lab session. In the lab session, I will demonstrate this k nearest neighbor by taking some data samples, and I will demonstrate how classification is done. You will understand much better. Okay. So this is a simple algorithm. Assume parameter k, which is, this is a user defined. It's a trial and error. I can take 5, 10, whatever it is. The number of nearest neighbors. Calculate the distance between the, how it is finding the nearest neighbor? It is just through the distance principle. Euclidean distance. It's called Euclidean distance. There is a formula in MATLAB. Directly it will calculate. There is a simple formula behind this Euclidean distance. You need not have to memorize that formula, or you need not have to write coding for that formula. Already everything is there. Just to use the function, it will calculate the distance between the unseen sample and all the samples in the training set. As a result, you get a matrix called DM. DM is called Euclidean distance measure. Short that DM, DM is having a single value for each. See, you are having 100 samples. You are taking one new sample. One sample is for distance is determined with all the 100 samples. Hope you understand. Okay. So one sample distance with respect to all the 100 samples. So DM will be a single vector array with 100 values. Then you sort that array. You find which is the top, which is the lowest. Sort the array and determine the first nearest neighbors. First 10. Say I have kept k equal to 10. First 10, which is very close to the unseen sample. You find it and gather the category of that and find the label, class label of those closest samples, and as a result predict the class label of the unseen sample. Okay, so this is the simple algorithm which is followed for the k nearest neighbor. Do you have any doubt in this? In this, because if there is a board, it will be easy for me to explain. Since there is no board, I'm just manually I'm telling everything through words. If you have any confusions, please let me know. I will clarify. Is it okay? Shall I proceed to the next algorithm? Yes? Hello?
Yes, ma'am.
Okay, thank you.
Yes, ma'am.
So, yes, thank you, thank you. The second classifier, see, I told I'm going to discuss 5. One is completed. Second one, multi-layer perceptron classifier. It's a simple neural network classifier. Okay, what is perceptron? It is simple feed-forward network. You have already studied or you have used for your project work or research work. Multi-layer feed-forward neural network. It is similar to that. Perceptron means output will be a linear model. Okay, it is not a non-linear. Output is a linear model. That is like a 0-1 approach, yes or no approach, something like that. So multi-layer perceptrons are general purpose flexible non-linear models used in problems where there is a little knowledge about the relationship between the predictor and the response variable. Predictor is the input, response is the output. Okay, so here this is the neural network architecture. You are very much familiar about this. You have 3 layers: input layer, hidden layer, and output layer. Output layer is only a single neuron will be there. You all know the concept of neural network. So in the input layer, the number of input neurons should be equal to the number of input variables. So the size of the input layer is fixed for any problem. If you have, see, now we are using feature vector. So what is feature vector? Z matrix. What is Z matrix? Z1, Z2, etc. Zm. So the number of neurons in input layer is fixed. It is m neurons. The number of neurons in the output layer is fixed, only 1 neuron, because you have only one output, one classification. Whereas the number of neurons in the hidden layer will vary, and that is a trial and error process, or you have to optimize the number of neurons through repeated trials and see which will be the optimum value of number of neurons in the hidden layer. So this is the simple architecture of a multi-layer perceptron classifier. What are the steps involved in the algorithm? Step 1. Initialize the network with all the weights. So here you have 2 types of weights: input weights and layer weights. Input weights are nothing but the weights of the this is the simple axons which is running from the input layer neuron to the hidden layer neuron. It is developed from our biological system only. So biological neurons are only here called as neurons, and these are the nerves which is connecting that is axons which is connecting the various neurons in our brain. Similarly, that only carries weight. Suppose if we touch a hot object, immediately we remove our hand. How that is possible? Because the signal is sent to the neuron, immediately the neuron sends a stimuli to the hand, take the hand, okay, back, something like that. That is the concept behind the artificial neural network. So this input weights initialized to some random numbers. So this is going to be a matrix. What will be the size of this input layer matrix? It is the rows will be m, because the number of neurons is fixed here. Okay, we don't know the number of neurons in hidden layer. Assume some h is the number of neurons in the hidden layer. So the size of this matrix will be m cross h. And you have to initialize that m cross h matrix with some random numbers between -1 and 1. Present the first train. You have a train pattern of 80% samples. Out of 100 samples, 80 samples you have reserved for training set. You present that 80 sample data to the input layer. So what you are presenting? 80 cross m. 80 is the size of the rows. Okay, that is the number of samples. M is the number of features. So 80 cross m matrix here you are presenting. Here you are having m cross h input layer weight matrix. Compare the output with the target value. So what will happen? Some processing happens in the neuron. So for processing, there is a function called activation function. See, neural network is another big topic, my dear participants. I have to take one more session. Just I am giving a glimpse of some important keywords. You just refer in Google and study in detail if you are not aware. Okay. So this is the activation function. Here we will be having some nonlinear function like tan6, sigmoid, some functions. Yesterday even our Prince sir has told about it. So tan6, sigmoid will be there. That function will process the whatever signal comes here, and the processed output is given to the next layer. Okay, accordingly the weights are updated, and finally the output we get the y output. This y output the weights are updated, with the actual output, and the error is the y output. So this y output is 87 with the actual output, and the error is the y output. So this y output, so we will have 80 remember for the error is the y output. So this y output, so we will have 80 remember for the error is the y output. So this y output, so we will have 80 remember for the error is the y output. So this y output, so we will have 80 remember for the error is the y output. So this y output, so we will have 80 remember for the error is the y output. So this y output, so we will have 80 remember for the error is the y output.